Welcome, folks. This talk will be about Azure Durable Function. Now, this is going to be a deep dive into the new Durable Function V2 feature. Now, some of the features that we'll be talking about includes entity functions and eternal functions. Now, to get started, let's talk about a difference between what makes Azure Function and Durable Function two separate, distinct products. Okay, so first and foremost, Azure Function is meant to be serverless. It will start its execution from the beginning to the end from a single host that's chosen on the Microsoft Cloud. So it's serverless, and we don't know what host it will run the function on, but we do know is that every function is going to run from beginning to the end on a single host. So just to make sure no function ties up these hosts for extended period of time, that you may or may not be aware that Azure Function has a default runtime of 5 minutes. So after 5 minutes, if the function has not yet finished, by default, the function is ended. Now, with the configurable parameter, you could extend it to 10 minutes, but the bottom line is the Azure Durable Function is meant to address that regular function must somehow get terminated within a short period of time because it has no persistence. It is stateless. It executes in response of a trigger. And once the logic is completed, it goes away. And the next execution of the same exact function may take place in an entirely different host in the Azure cloud. So let's imagine we have this situation where we have one Azure function within the 5-minute span. So let's put a time here, 5 minutes. So within a 5-minute span, let's say we go out and call a few additional HTTP APIs or some external services or our own services. So let's imagine these are all separate functions that we're calling. So notice over here, we're paying for 5 minutes of runtime. Now, even though, let's say this HTTP takes 1 minute, this HTTP takes 2 minutes, and this API takes another minute. Now, this will add up to be 4 minutes altogether. Now, understand double billing describes that with Azure functions that you'll wind up paying twice, where one function executes while waiting for another API to complete. Now, there is a double billing that takes place. Now let's switch over to the durable function and see how things work behind the scene. Now when you create a durable orchestration, which is triggered by some sort of client application. So it's really important to know that an orchestration is a special type of function. Now you have a normal Azure function that serves as a client. Now that client will receive an orchestration client that can start a new orchestration. Now let's call this thing the orchestration. Now within this orchestration, we can see there are various commands. Now we can imagine that every time a command is to be executed, when the syntax of await occurs, that means the caller can go out and wrap up what it's doing. In the meanwhile, while it's awaiting, the orchestration suspend. So in other words, let's say we have 5 triggered queue messages. So let's say we have 5 messages in a queue that triggers our client app. So that creates 5 instances. And each one is represented by an instance ID in a durable function world. Now, this instance ID can run at different stage of the orchestration. So in other words, let's say the orchestration entails 5 different activities. Now, one instance may be on step 3, one instance may be on step 4. This one can be just barely started. This one can be just barely started. This one is almost, well, let's say run to completion. So now imagine each one of these is a statement at some point that involves an await. Now, await is an interesting keyword because when you look at await, immediately follows that keyword is usually an async operation. So that async operation is a good indication that we should suspend the orchestration until the async operation give us a result back, and then we can resume. Now let's take a look at this instance. So imagine step 1 is completed. Step 2 is completed. Now we are on step 3, which we are awaiting for a result to come back. So understand that the fact that 1 and 2 have been deterministically executed, the Azure Durable Function records the outcome of these deterministic function. So let's say this await in step 1 has produced a value of blue box. And step B, the results of await produce a orange box. Now the result value isn't important. The important thing is that because they are deterministically executed, when we are awaiting for step 3, at that very moment, the runtime memory of this function is free to be destroyed. For that, whenever this awaited task completes, the Azure Durable Function replace step 1, replace step 2. Replaying it does not mean re-execute it. Replaying means because step 1 and step 2 has already been deterministically executed, we know that every time we run it, we're always going to get a blue box back, we're always going to get an orange box back. Therefore, rerun these code allow us to reconstruct the state at the moment that the step 3 is suspended. Now, it is this replay mechanism allows this instance to be reconstituted in another server elsewhere. So in other words, I can perfectly suspend one instance of this orchestration on any random server as long as the state of all previous steps are captured and replayed on the instance that's rehydrated. Okay, so this allows us to essentially perform an event sourcing style. Okay, so that you will not see effect of that while you run these Azure Durable Function locally on the emulator. Now, because obviously everything that calls back is going to be on the same machine, right? But in the Azure Cloud environment, you could have a task that goes out, takes 3 hours to finish what it's got to do, comes back, and the orchestration will continue on an entirely different host. Okay. Now remember, the benefit is twofold. Now, one, from the customer, we don't have to pay for that 4 hours that we're waiting. Now, for Microsoft, that also means you don't have to idle spin a bunch of things until those remote things come back. But at the end of the day, Microsoft don't really mind that, except that there are competitions from Amazon, there are competitions from Google, etc., that might offer something more efficient. And then in that case, that the client or the customers obviously will take a look at cloud provider A and B and find out which one can save me more money. So at the end of the day, it's just ways that cloud provider can duke them out. All right, now we're going to take a look at some of the basic life cycles of a durable function. Okay, so what I have here is some basic activity just to show you how the Azure Durable Function works. All right, so if you'd like to get a copy of all the code that I'll be showing you, please feel free to go to github.com/VictorChin, and you'll find that on the Expert Talk Durable Function section. It's the same source code that I'm talking over on this video. All right, and I'll be developing this durable function in Visual Studio using precompiled C# code. I just don't see developing any of these in the portal. Makes a whole lot of sense. All right, so I have a basic activity. I have a set of client functions. All right, so I'm going to start by walking over some of the basic commands. Okay. Now this is going to be my client function. It listens on the HTTP based on that route. Okay, based on that route. Now it depends on the activity. I'll run one of the two things: a timer sample and a Fanout sample. Okay. Now this two activities just to show you the basic life cycle of durable function. All right, so I'm going to start up this client app, and the first one I'm going to show is the timer sample. Now I'll be using a local storage emulator. Now at the end of the day, all these orchestration function needs a permanent storage for its replaying and reconstitute the state of these durable functions. So it's going to connect to my local emulator. Now once this initializes and my local emulator is running, I should be able to go to my local emulator using the Cloud Explorer and take a look at my tables. Now during this demonstration, all of my orchestration will persist into a test hub. Now understand that test hub is where all this history lives. Now it's configurable through the host JSON. Which hub do you want to store these to? And we typically use that to help out versioning. So for example, I may have a timer version 1 and I want to have all of the instances in hub version 1. And I'll create a hub version 2 once I decide to change how the orchestration operates. All right. So now when the orchestration function is running, it tells me the 3 endpoints that I need to use to start the orchestration. All right, so this is the REST client built into Visual Studio Code that can help me quickly send some requests and see the results. So I'm going to send a request. Now notice following the HTTP standard, any kind of long-running operation immediately returns to 202, HTTP accepted. Now this accepted would tell you retry after 10 seconds at that location. So usually for any type of long-running operation, tells you retry after what amount of time, 10 seconds, and where to go to find the results. All right, it also gives you a bunch of URIs. URI that tells you how to get status of this instance, how to submit event in case your durable function is waiting for an event to occur, like in human interaction. Now terminate that instance and purge all the history and delete. All right, so these URI can then be copied and pasted to find out the status, or you can simply follow. Notice the status query is the location. Okay, so it's the same exact place with the same authorization code. All right, so this is where you can find out the status. Should be after 10 seconds. All right, so I can copy that. Notice these two aren't exactly the same. Okay, so now I'm going to paste that and send that request and find out what's going on here. Okay. All right, so here is the result of the execution, which says everything is finished. Okay. The timer sample is completed. This is the output. Okay, and you notice 30-second timer created a 30-second gap between this message and the next message. All right, so let's see our code. How does our code accomplishes that, and what we can learn from these codes. All right, so notice here, this function uses an orchestration trigger. So unlike normal functions, normal Azure non-durable version of the Azure function that listens on the dependency of tables and queues and blobs, etc., this is to be triggered by a client function. So notice the client function in of itself is a regular Azure function, nothing durable about it. Okay, so this is a normal function. It can be triggered by an HTTP Now, for the ease of demonstration, I'm using an HTTP trigger, so I can on-demand trigger this orchestration. It could just very easy be triggered by a queue message, triggered by a table, triggered by all sorts of other things that's compatible with normal Azure non-durable functions. Now, once I have added the package and that namespace, I'm able to request injection of a durable client. Okay, so this is serving as an input to my Azure function. Now, the purpose of this durable function is to spin up new activities. So the activity that I'm spinning up is the timer sample, right? So that's why I use activity/timer sample in order to trigger that function. Okay, so activity/timer sample, my root will cause that function to be started as new. Now, as soon as you start a new orchestration, you are going to get an instance ID, and then we return, well, we have an HTTP trigger, right? So an HTTP trigger naturally expect an HTTP async results, request response, right? So this is creating a response that includes how to check status, how to trigger the event, how to stop the instance, how to delete history, etc. So this is what's generating that response we saw in Visual Studio Code right here. All right, so notice that start new means the orchestration begins. So here is our orchestration trigger. This is the durable function. Okay. Framework. So this is the durable function framework. So we prepare a list of strings. So notice this is one task that's deterministically will give you an instance of list of strings. Deterministically. Now while we add a line, so notice await context dot call activity async. This call activity is awaited upon the name of the function and the parameter. The return type is going to be a string. Now let's take a look at what happens when this line actually runs. To see that, I'm going to bring up the Azure Test Hub name history. All right, so now I'm looking at the Azure table storage used to Azure storage table used to store the execution history of this Azure Durable function. So you notice I'm sorting by the underscore timestamp. Okay, and let's look at the event and see how we can match up with what happened. So the start new begins the timer sample. So you can see that pretty much this line will match the beginning of this function. So it tells you that orchestration started. Okay, so it ran through that line, it ran through that line. So now we are here ready to go ahead and execute that activity task. All right, so once that has been scheduled, notice immediately after is that our orchestration is done. For all intents and purposes, the memory space that used to occupy this can just go out because it is now transferring the control to another function called timer sample underscore hello. Until that finishes, there's nothing for it to do. So quickly, a second later, this is already completed. Sorry, a second later, you can see the task completed. So that is when this timer sample underscore hello has completed. So we are waking up the orchestration again to continue. So it ran through this line. Now this line has no await, so there's nothing it needs to do. This creates a delay timer. Now this is an artificially injected timer that's going to hold up the execution for 30 seconds. So you'll notice that when I go for the task delay timer, I'm going to add a string 30 seconds timer started at. And it also noted, hey, the timer was created on line 29. Okay. So at some point the timer expires. Okay. So notice I am doing a wait delay timer. And my orchestration goes back to sleep until the timer is done. So notice as soon as it fires, okay. All right. So notice this is when it's scheduled. And this is the time that actually fired. So 30 seconds later. Okay. The timer is created at the 12 seconds and it's fired at about 42, roughly 30 seconds later. So the orchestration goes to sleep, and then once it's done, it restarts again and it runs the next sample hello. So notice each one of the previous results is deterministic. So by the time it wakes up, this time, for example, this line wakes up the orchestration, it simply replaces all the previous results to bring the state of the durable function back to the moment it was suspended. So here I'm highlighting the fact that every time the timer that's created through the context. So notice it's important that you don't want to use system thread timer because the system.threading.timers actually blocks the thread. Okay, so it's not what we want. We want to use the durable function context create timer. So this timer uses the durable function framework in order to not block the execution. Okay. All right, so the rest is just chaining. So this is also an example of chaining multiple durable function activities. So each one of these say hello is just an activity trigger. Okay. Now I've also included another sample called Fanout. Okay. So I'm going to bring up the Fanout. Okay. Now the Fanout isn't that much different, except I'm trying to demonstrate two things in this Fanout function. The first thing I'm demonstrating is that the fact that you can call all these async activities without the await. So notice now this actually have await. Therefore, what's returned is task of durable HTTP response. Now, what's interesting in this example here is that my HTTP call is made through the context. That's interesting. That means the context has somewhat of a built-in HTTP client that can go out and call it. Now, why do I want to make use of it? The reason is automatic 202 handling. Now, of course, what you're seeing me doing here is simply grabbing web pages, so you won't actually see the effect here. But imagine that this actual request goes out and the URI returned a 202. And remember earlier, whenever you see a 202, you are going to get a retry after and a location to retry. The context HTTP client will make a GET request or POST request or whatever, and if it gets the 202 response, it will try again after that amount of time. So you don't have to write that if 202, save the URL, wait X amount of time, and then go check again. So if you have long-running operations, context a quick, convenient method. Nothing that you cannot do yourself with a good old HTTP client object yourself. It's a convenient wrapper. So if you just want to go out and call HTTP APIs, you don't have to write a separate function and inject an HTTP client factories and all that funny business anymore. So here I have three things. I have three websites I want to go talk to. Fan in means I can wait until all of the tasks are done. So this await is awaiting on all of the tasks because it's not critical that I need to process one result immediately. I rather wait until all of them are done. Okay, so at least all of them has some kind of results. So in this example, I have one orchestration that will perform three tasks in a fan-out manner. Okay, and once they are all completed, I will then safely access the results because by then it must have been done. So I just want to print out a few things and put them onto the output. Okay. All right, so I'm going to send the request Fanout. I'm going to follow the location. This is a pretty quick one, and the location will then tell you it's completed. And these are the 3 web page sizes of the 3 website. Okay. Now this is for non-time critical stuff. Remember, I'm only showing this because I'm recording a very short video and I need to show you the results. Now, usually if you have something that takes hours or even days, okay, you can use this to run it behind the scene. For example, let's say you're transcribing an audio using audio to text with the cognitive services. Now, understand that if you have a 4-hour audio clip, it's going to take 4 hours to transcribe it. There's no magic ways to speed it up and recognize them faster. So in this 4 hours, you don't want your Azure function to continue operating because you can't, number one. And number two, it's an incredible waste of resources to do just that. So here, your alternative is to use Azure Durable Functions. And in this case, you can fire up 5 audio clips and have them recognized in parallel. And then when it's all done, go grab the results and then save them back to a blob of some sort. Okay, so remember this Fanout is a quick way for parallel long running task. Now, folks, if you're listening to this session this far, you spent about 27 minutes. Thank you very much for staying with me on this session. Now I'm going to tell you a little bit about entity functions. Now, this is pretty interesting. I first came across something like this when we programmed against Service Fabric. So let's understand what entity function is. An entity function can be a plain old C# object. So here I have a folder called entities, and I created a loan entity object. It's a very simple concept. You have a loan, you initialize with a loan amount, okay, and you can add transactions. Okay, so these transactions will be continuously applied to the loans, and there's only 2 kinds of transactions. You either repaying the loan or you borrow some more, so it adds balance on top of the loans. Okay, so you have a get balance. The get balance simply does a event sourcing by retrieving every transactions and compute the current balance based on the transaction. This is a very simple list of transactions. Now, what is important is there is no database backing this. I am not using any kind of data stores. I'm not using an Azure table. I'm not using SQL Server or Postgres or Oracle database, none of that stuff. It's just a plain old object that has these states. Okay. Now, what's interesting is, so if you can imagine this Azure Durable Fabric, I like to call it Fabric because I don't have any other way to call it. And this is run by Microsoft. Okay. So whenever you introduce a entity function, understand that this function will be accessible anywhere within this Azure Durable Function. Okay, so if your code have access to it and you know what the ID is, okay, within that storage, so this is your storage account. Okay, so your storage account will store the state of these entity function things. So think of them as objects, but rather than living in memory, it's living across the storage account. Okay. Your storage account is providing the persistence behind the scene. So every object is simultaneously accessible as they were in memory as soon as you need access to it. And they will stay in your storage account as long as you keep it around. Okay, and it's automatically partitioned, and they're durable. Okay, so think of this entity function. I would just take away the word function and just call it entity. Okay. Now remember, the entity will be stored within the storage account. Every entity has an entity ID. And that's the unique identifier for each and every one of these pink boxes you see here. So I can have a loan for Victor, I can have a loan for Bob. Now, when I access it, it will always be available. Okay. When I don't need to, they do not disappear from memory, like the old C# programs. In C# program, all your object is in memory, right? In the heap. And when the machine shuts down, your heap is gone. That's why you constantly store them in the relational database to provide durability. Now, durability, anyone? That durability is the essence of the durable function. We no longer need transaction log. We no longer need redo logs to provide us with the durability that we traditionally need from RDBMS. So let's see how that works. Actually, seeing how it works is the easy part. I have a class, a POCO, that implements an iLoan interface. And the iLoan interface simply describes that any object that implements that has initialized loan, add transaction, get balance, and get transaction history. So these are the things I described in the iLoan. So no big deal here. Okay. All right, get transaction history, get balance. Now, one more thing that you notice that I marked all the property public because they all have to be serialized into JSON, and I really don't want to mark every single attribute. So I just say serialize all public members unless I opt it out. Okay, so just serialize everything. Okay, make life a little simpler. All right, so here I have a client function. The client function begins with an account name. Followed by the action. The action can be one of the four things. Well, my loan can only do four things, so I'm going to try each and every one of them. Initialize a loan, add a transaction, get balance, and list transactions. And amount is optional because I really only want amount when I'm initializing a loan or I'm adding a new transaction. I don't need amount for any other reasons. All right, so with these four with these four activity in place, I have a start new async based on the action. So that means I have four other function here, which I put them under orchestration, entity orchestration. So this is the orchestration for initialize loan, add transaction, list all the transactions, and get a balance. So in an initialize loan, okay, I'm being a bit lazy here, so I'm getting all the things back as dynamic, and I'm just going to access the JSON account and the amount passed in. Now, this is the interesting thing. I'm calling a create entity proxy. It's a generic function that returns a pointer to an object that implements iLoan, which is my entity object. Okay, this is smart enough to scan. Again, Azure Durable Function, Azure Function make a lot of use of the reflection capability. So it's going to find out what object out there implements the iLoan, and it will find this class iLoan being the one that implements iLoan. So it will instantiate an object in a durable function with that account as the unique ID. So understand that it's my entity key. Okay, and this will initialize the loan with a given amount. Now, when the orchestration of the add transaction occurs, it will simply, again, these codes exactly the same, and I'm just going to call a function add a new loan transaction. Transaction is just simply made out of the amount, whether it's repay or borrow. So right now I just fix it to repay and the current date time. Now, folks, it's also very important to always use context current UTC date time to be compatible with the Azure Durable Functions. Normal datetime is not deterministically executed because every time you call, you get different value. This one was the deterministic version, so it's compatible with the durable function. All right, so I have add transaction, I have list transaction, so my code is still running, and let me go ahead and try this out. Okay, so I'm going to start initialize a loan for myself, Victor, initialize a loan for 15,000. I'm going to send a request. Okay, I can just change that to say I want to create another loan for Bob, just for the sake of it. And I'm going to create another loan for Tom. Okay, so you can imagine that my durable function now has 3 entities: Victor, Bob, and Tom. Okay, and I can add transactions for Victor that repays 500, and I can say Bob just repaid 1,000. Okay, and then I'm going to say Victor get balance. Okay, right? These are all durable functions. So once you call it, you're gonna have to follow the status query to find out what is my balance. So notice that is my balance. All right, so I'm going to also make another request to list out all the transactions, and you'll see that this is the transaction I made. It has done a 500 repay. Okay, type of transaction 0 is repay, just that. All right, so if I make another transaction, let's say do a Victor transaction 1,000. Okay, and it is done, and I'm going to do a send request, and then look at it. All right, so now I have 2 transactions. Now, what's interesting is it is a durable entity. So if I stop my execution, so understand my C# memory space has just been wiped clean. There's no more heap, there's no more object, there's no more anything. But yet, all of my entity are persisted into the storage. So when I relaunch it, I made another demonstration. So in the client functions, I've made a get loan balance. Now this get loan balance is a standard HTTP trigger. Unlike the previous example I showed you, where it's a iDurable client, this time is an iDurable entity client. Okay, so notice this is a little different than the one I've showed you earlier. Okay, so this one is a durable entity client, while the ones I did before is iDurable client to start the orchestration. So what this means is any function that's triggered by anything, the function themselves needs not to be durable functions. Notice this can just be any regular function that starts and ends. There's nothing durable about this client function. Now what's interesting is having a durable client injected, that means as long as I know what account, Victor, Bob, or Tom, okay, I'm going to construct the entity ID. I can use the client to read everything back into a loan object. So you can imagine the state response effectively is a loan object. Okay. It's an entity state response of loan. T is loan. So notice it tells you that the generic type is loan. So if it doesn't exist, I'm going to return a 404. So if you send me Joe or John and I don't have a loan for Joe and John, I'm going to return a 404 and say there's no loans associated with the account. And here, if I can find it, I'm going to take that and find the entity state and cast it back to the loan object. And then I can give you an object of all the transactions and all the results. Now the key things to take away is these entities lives within this durable storage backed durability feature. Don't really know how to put in the right word. The idea is these entities don't die. There's no need to serialize them into a relational database or any other database unless you need to analyze them, but these object lives within the realm of the durable function. Okay, so let's see how I can trigger this function. Okay, notice loan balance followed by the account. Okay, so in this case, I'm going to make a request. All right, so I'm going to make a request, a loan balance slash Victor. And notice this is not a durable function, so I'm not getting that 202 accept. I'm getting real-time response. So this is now give me the account name, the balance, the transaction in JSON arrays. Okay, and I can also check out Bob. Okay, so let me send that request, and that's Bob's storage. No relational database, every entity stored in this durable environment. So this is one of the new features that's available with Azure Durable Function V2. It's a very powerful thing, gives you actor like programming model. So actor, what I'm referring to is that imagine there are 5 people at the very same time invoke add a transaction. Okay. It is the job of the durable function to serialize these calls so all the transactions are one after another. So notice I'm not using a concurrent list because I don't have to. I don't need to use a thread safe list because the call into the add transactions are always serialized in a manner that's one after another. There's zero chance where 2 execution threads going to perform the same instruction within the method at the same time. So I don't need to use a thread safe collection in this example. Now, please do not confuse this with locking of the object. In this talk, we won't go into how to perform critical sections of a method and perform transaction across object. Those are available in the developer guide to durable entities. Okay, so you may want to give this a read through, okay, and it will give you pointers of how to ensure that critical regions are locked. Okay, so because it's not that your function will cause race conditions, it's the services that your function may cause race conditions. So those times you want to make sure there's a way to arrange the call that's made through those entities. Okay. All right, so there's some good read in the Microsoft documentation, and this is our short section. And I thank you for your time. My name is Victor Chin, and I'll see you next time on some other things. Leave a message and let me know if there's any question I can help you answer, or if there's any other topic you want to see. Thank you very much.